This video is for Math 70. It's for the sample final exam. So it'll provide you with an answer key, and if you have any questions about how to do the problems, you can see how to do the problem in the video. I do encourage you to complete the sample exam on your own and then use the video to check your answers so that you're prepared for the final exam itself. Alright, so the last page, the final page in the exam will be a formulas page, and I'll point that out during the exam. So the things that are on that, you can take a look at the PDF yourself. You've got the slope formula, the slope-intercept form, let's see, and the rules of exponents are the main things on there that will be helpful for the exam. So let's take a look at these. Problem 1 is a substitution problem. We've got this expression, y minus x squared in the numerator, x plus y in the denominator, and we know that x is negative 4.82 and y is positive 6.08. And so we want to evaluate this expression for these values of x and y, and then at the end, round our answer to the nearest hundredth. Okay, so let's see. If we substitute our values in, y is 6.08. This minus sign comes with the formula. We'll get a second minus sign from the value of x, and then we'll calculate that and square the answer. You can't square these individually because it doesn't work that way. All right, in the denominator, negative 4.82 plus 6.08. Okay, well, maybe I'll do that first. Negative 4.82 plus 6.08 in the denominator. So that'll come out to be 1.26. In the numerator, inside the parentheses, that negative and negative will make a positive, and then I believe that'll be 10.9. Let me double check that. Yeah, 10.9, and don't forget that squared. Okay, so then we're going to square that 10.9. We'll get 118.81 divided by 1.26. And then we'll round our answer to the nearest hundredth, which will be 94.29 for problem 1. Okay. Problem 2 is a simplifying problem. Notice there's no equal signs in problem 2. It's not an equation. We're not solving for anything. What we want to do is simplify the expression. So we start out 5 times parentheses 4 plus x, and then minus 3 times parentheses x plus 9, and then minus 7 and minus 2x on the end there. So what we need to do first is to distribute these two, the 5 and the minus 3, into the parentheses, and then once we get done with that, then we can look to combine like terms. So in the first set of parentheses here, we'll get 20 plus 5x minus 3x minus 27, and then that minus 7 and minus 2x on the end. So here are the terms that involve x. You've got a positive 5x, and then minus 3x and minus 2x. That makes 0, and so we can just leave that out. What we need here are these constant terms. 20 minus 27 is negative 7. Another negative 7 will make negative 14. All right. Now, problem 3 is an equation. You can see the equal sign there, and we need to solve this and find the value of x that makes it true. So negative 0.5 times 15 minus 0.35 times x plus 5 3.5 times 15, that'll be negative 7.5, and then minus 0.35x, and then minus, let's see, 0.35 times 5, 1.75. 0.75x. Now we can combine our like terms over here first if we want to. We can add this 0.35x to the other side if we want to. I think I'll combine these together first. Negative 7.5 minus 1.75, negative 9.25 minus 0.35x equals 0.75x. And now we'll add this to the other side. So these cancel out. On the left side, we've got negative 9.25. And over here, that'll be 1.1x. And then to solve for x, we just need to divide on both sides by 1.1. And so these cancel out. And x is going to be negative 8.409 with the 09s repeating. Okay. Problems 4 and 5 are also equations where we need to solve for x. So let's take a look at problem 4. We've got 2/3 x plus 3/4 equals 3x plus 27 over 8. Okay, so this problem works just like other equations. We want to collect all our x's on one side, collect all the constant terms on the other side, and then isolate the variable. So here I'm just going to subtract the 2/3 over to this side. So these cancel out. Now we've got 3/4 equals. Here, 3x minus 2/3 x. You can do this on a calculator. I'm going to make this 9/3 x minus 2/3 x will leave you with 7/3 x. And then plus the 27 over 8. And then we need to subtract the 27 over 8 over to this side. So 7/3 x equals, let's see here, this is going to be 6/8 minus 27/8 should give us negative 21 over 8. And then whether you divide on both sides by 7/3, I'm going to multiply on both sides by 3/7. Then I can cancel that. 7 into 21 goes 3 times, and we'll end up with negative 9 over 8 equals x. Now, if you did this using decimals, you're going to have to be careful because this is a repeating decimal, and so you want to include a lot of that repeating term, otherwise your answer will be off in the end. But down here, if you call this negative 1.125, that's the same as negative 9/8, and that's fine. Okay, problem 5, a little bit more complicated. Let's see, what do we start out with here? Negative 3 times x plus 2 plus 5x minus 4 equals 7 times x minus 3 minus 8. Okay, so here's the equal sign. We need to simplify on both sides, collect all our x's on one side, collect all the constants on the other side. So this will be negative 3x minus 6, and then plus 5x minus 4 equals 7x minus 21 minus 8. So over here, we get 2x minus 10, and over here, 7x minus 29. Let's see, so I'll subtract the 2x on both sides. Negative 10 is 5x minus 29. and then add the 29 to both sides. So 5x is equal to 19. Divide through by the 5. You can call it 19 over 5 if you want to. Otherwise, looks like it's going to be 3.8. Okay. Problem 6 is one of these what are called literal equations, and so this is where you have pretty much all variables. B equals a plus xy, and we want to solve for x. So this works just the same way as the other equations do. We need to get the x by itself. So I want to subtract the a on both sides. Xy equals b minus a. And then to isolate the x, we're going to divide on both sides by y. And so x is b minus a divided by y. Okay, now we get into the word problem section. Problem 7, we want to translate this sentence into an algebraic equation, and you don't necessarily have to solve it unless the instructions ask you to. So problem 7 says 5 times the sum of a number in 12 is the same as 4 subtracted from a number. Okay? So I'll let x be the number, and we want 5 times, and then where it says the sum of, that's an indication that you're going to want parentheses. A number and 12. The sum of a number and 12 is going to get multiplied by 5, is the same as 4 subtracted from a number. So if we subtract 4 away from a number, we would write that as x minus 4. Okay. Problem 8 is one of these mixture problems. Let's see, a grocer wants to make a 60-pound mixture involving walnuts and Brazil nuts, and wants to sell that mixture for $5.99 a pound. Okay. The walnuts sell for $3.99 a pound. And the Brazil nuts sell for $7.59 a pound. Okay. How many pounds of each should the grocer include in the mixture? Well, the key here is that you want the value of the mixture to be equivalent to the value of the nuts that are going into the mixture. So the value of the mixture is 60 pounds times $5.99 a pound. And so if we multiply those two together, we'll find out what the value of that 60 pounds of the mixture is. So 60 times $5.99, $3.59.40. So that's the value of the mixture. Now, we want the value of the walnuts and Brazil nuts to be equivalent to this. Now, we don't know how much of each we're going to put in, right? So if I call this one X pounds and this one Y pounds, then we know that X plus Y has to add up to be 60, because that's how much we want in the end. All right, and the value of each of these is going to be X pounds at $3.99 a pound, and Y pounds at $7.59 per pound. Okay, now the key here is to get rid of one of these variables by substituting. So if I move the x over here, we can see that y is going to be 60 minus x. So I'll plug that in for the y, and then we'll be able to solve this equation, 60 minus x. Okay, so this is 399x, and then we have to do 759 times 60, 455.4, and then minus 759x, 359.40 on the other side. Okay, so I'm going to combine my like terms. 399x minus 759x will give us negative 3.6x plus 455.4 equals 359.4. And now we'll subtract this 455.4 to the other side. So negative 3.6x is going to be equal to negative 96. And then we divide by negative 3.6. And x is 26 2/3 pounds. And then to find out what y is, we just do 60 minus that. And y should be 33 1/3 pounds for the Brazil nuts. Okay? All right. So that's the first of those two word problems. The second one is that word problem that's about filling a tank. So let me make some space here. Okay, so in problem 9, we want to fill a 1,900-gallon tank. And we've got two different spigots, one that produces 15 gallons per hour. And the other one produces 55 gallons per hour. And we know that the sum of the running times of the two spigots is 60 hours. So let's say x is the number of hours for the 15-gallon per hour spigot, and y is the number of hours for the 55-gallon spigot. So we know that x plus y has to add up to be 60. And then we also know that 15 gallons per hour at x hours plus 55 gallons per hour at y hours should add up to fill that tank, 1,900 gallons. Notice we don't multiply the 1,900 by anything. Do the same thing that we did in the last problem. Find out what y is equal in terms of x, and then substitute it in here. 15x plus 55 times 60 minus x equals 1,900. And then let's see here. We distribute 3,300, I believe, is what we're going to come out with there. 55 times 60. Yeah, 3,300 minus 55x equals 1,900. So now we can do 15x minus 55x will leave us with negative 40x. Plus the 3,300 equals 1,900. Subtract the 3,300 over here. So negative 40x is going to be equal to, looks like negative 1,400. Yeah. And so then we just divide on both sides by negative 40. And x is 35 hours. So we're going to run the 15-gallon per hour spigot at 35 hours, and if we do 60 minus 35, 25 hours on the 55-gallon spigot. Okay. Let's see here. Now, problems 10 and 11 are graphing problems. So, let's see here. I'll put a grid up on the board here. And I'll turn the lights down as well so you can see it better. Actually, I'll turn them off. I'll turn the lights off once I get ready to graph, because I'm going to have to put this in slope-intercept form first. So let's see. All right. So first in problem 10, we've got 4x plus 3y equals 12. Now, you can make a table of values for yourself if you'd like to. I'm going to do this by slope-intercept form. I'm going to get the y by itself, graph the y-intercept, and then use the slope to find a couple more points. So we'll have 3y is negative 4x plus 12. Divide everything through by 3. And so our equation says y equals negative 4/3 x plus 4. So that's what I'm going to graph. So let me get the grid back on here, and then I'll turn the lights down so you can see better. Okay, so this y-intercept at 0, positive 4 is going to be right there. X is 0, y is positive 4. And now the slope is negative 4/3. So I can go up 4 and back 3, or I can go down 4 and over 3. And then we've got plenty of information to graph our line here. And so it would look something like that. Okay, let's see. Turn the lights on. Now notice that the x and y axes were already drawn on this grid. On your test paper, you're just given a plain grid. You will need to draw your x and y axes on that grid when you're doing your graphing. That's a very important aspect of graphing because it's the foundation for the entire graph. It communicates a lot of information to anyone who's looking at the graph. There we go. All right, problem 11. Let's see here. This one starts out 3y equals 12x plus 9. So all I have to do here is divide everything through by 3. So y is 4x plus 3. And then we need to graph that one as well. Okay, so I've got the x and y axis here already. All my tick marks are labeled, so I'm ready to graph. The y-intercept here is 0, positive 3. And then the slope is 4 over 1. So I can go up 4 and over 1. I can go back 1 and down 4. And then we'll get a line that looks something like that. Okay. All right, now there's a couple more graphing problems where you don't have to make a graph. So let's take a look at those. Problem 12. We want to find the equation of a line in slope-intercept form that passes through the points -7, -5, and -2, positive 4. So the first thing we need to know about this line is what's the slope. Remember, you've got the slope formula on your formula page, and so that's going to say y2 minus y1 over x2 minus x1. So let's see, I'll start with the 4 for the y's, minus -5, right? This minus sign comes with the formula. this negative comes with the value of the other y coordinate. And then for the x's, because I started with the 4, I have to start with -2, subtract, and then we'll get another negative again from that -7. So both of these double negatives will mean positive. 4 and 5 is 9, and on the bottom, -2 plus 7 is going to give us positive 5. So our slope is going to be 9/5. If you want to call that 1.8, that's fine. We don't have to graph this, and so it's not going to cause any problems if you do that. I'm going to leave it as 9/5. So now we know y is going to equal 9/5x plus the y-intercept, whatever that turns out to be. So let's plug in our x and y coordinates. It doesn't matter which pair you choose, but you have to choose a matching pair. So if y is 4, that means x was -2. So let's see here. 4 is going to be -18/5 plus b. Let's see. I'll call this -3.6 and then add it to the other side. And so it turns out b is going to be 7.6. So the answer to the question is the full equation, 9/5 x plus 7.6. Like I said, if you want to call that 1.8x plus 7.6, that's fine too. Either one of these is correct. And these decimals won't make that big a deal, like I said, because we don't have to graph the line. Like if you're doing what we did on those previous problems where you want to use the y-intercept and the slope to graph the line, this would be a little bit tricky. All right, what else? Problem 13, we want to write a line that is perpendicular to the line -3x plus 4y equals 8. So we want it perpendicular to -3x plus 4y equals 8 and passes through the point 3, 2. All right. So again, the first thing that we need to know about this line is what's the slope? Well, if it's perpendicular to this line, then it'll have the negative reciprocal slope. So let's find out what the slope for this line is. Add 3x to both sides. And divide everything through by 4. So, here's the slope for the line that we're interested in. A line that's perpendicular to that line will have a slope of -4/3. Flip it over and change the sign. And we don't know what the y-intercept is going to be. But the fact that it passes through the point 3, 2 means that we can find out. So if we plug in 2 for the y and 3 for the x, 2 equals -4 plus b. Add the 4 over. B turns out to be 6. And so our answer is y equals -4/3 x plus 6. Okay. Problem 14, we want to find the x and y intercepts for the given equation, which is 6x minus 5y equals 30. So our x-intercept is where y is 0. So if we plug in 0 for y, we get 6x equals 30. And x is 5. So the x-intercept is going to be the point 5, 0. Y-intercept is where x is 0. So we'll put in a 0 for the x. -5y equals 30. Divide on both sides by -5. And it turns out that y is -6. And so the y-intercept is the point 0, -6. got a little diagram here with 2 points identified. This one is 0, 1,000. And then this one right here is 4 and 800. And so we've got a business purchases a computer for $1,000. 4 years later, it's worth $800. Year 0 is 2010. Year 4 is 2014. So we've got all that information in these points right here. So what we need to do is find the equation of this line. And once again, we need to know the slope. And so I'll do 1,000 minus 800 in the numerator. And then because I start with 1,000 on the top, I have to start with the 0 on the bottom. So this will be 200 over -4, which gives us a slope of -50. Now the y-intercept is right here. It's given to you in the problem, and so there's not really a whole lot more work to do. You can do what we did on those other problems and plug in one of these points to find out the y-intercept. You should get the same answer. Should be 1,000. So there's our equation. Y equals -50 times x plus 1,000. All right. Let's see here. Problem 16. We have a system of equations that we need to solve. 4x plus 12y equals 7. -8x minus 1 equals 6y. Well, there's a couple of different ways that we could go about doing this problem. One would be by substitution. Neither one of these equations really lends itself to substitution. You can still do it that way, but you should be careful because you'll be working with fractions. Okay? What I'm going to do is I'm going to set this up so that we can add the equations to each other. So I'm going to put the 6y over here and move the 1 back over here. So what we come out of this with is 4x plus 12y equals 7, and -8x minus 6y equals +1. Let's see here. I think I'll multiply the top equation by 2 on both sides. And so that'll cancel out the x variable. Here we'll have +8x plus 24y equals 14. So these cancel out and make 0. Here 24 minus 6 should give us 18y equals 15. And then divide on both sides by 18. So as a fraction, y is going to be 5 over 6. If you just divide 15 divided by 18, you'll get this 0.83 repeating. And now we need to find out what x is. So I'll take the y and plug it back in here. So 4x plus 12 times 5, 6 equals 7. So 4x plus 10 is 7. And then we just get the x by itself. And x turns out to be -3/4. Okay. Let's see here. Problem 17 is about the rules of exponents, and I encourage you to use your formula sheet. You've got the rules of exponents on your formula sheet, and I encourage you to use that. So here we've got -3 x squared y to the 4th getting multiplied by 2xy cubed, and then that's all being raised to the 3rd power. Well, we need to take care of this exponent right here first. Okay, so this one will stay the same. This one is 2 to the 3rd is 8. X to the 3rd is x to the 3rd. Y to the 3rd raised to the 3rd power is going to be y to the 9th. Now that we've taken care of that, now we can look at each piece individually. 8 8 times negative 3, negative 24. X squared times x to the third is x to the 5th. And y to the 4th times y to the 9th makes y to the 13th power. Okay. We've got one more of those to do. So, problem 18. What do we have here? Negative 2b to the third c on top, bc to the 4th on the bottom, and that's all being raised to the 2nd power. Now we can just raise everything in there to the 2nd power, but I'm going to do some canceling before we do that. Because this b will cancel out one of these and leave us with b squared. And this c will cancel out one of these and leave us with c to the 3rd. So we end up with negative 2b squared on top and c to the 3rd power on the bottom. And now I'm going to square that. So negative 2 times negative 2 squared is going to be positive 4. And then b to the 4th on top, and then c to the 6th on the bottom. Okay, let's see here. Problem 19 is about squaring a binomial. In this case, 3x minus 2. Well, what does it mean to square something? It means to multiply it by itself. So 3x minus 2 times 3x minus 2. Here we're going to distribute 3x times 3x minus 3x times 2. So that'll be 9x squared minus 6x. And then we do negative 2 times 3x and negative 2 times negative 2. And so then we'll get another negative 6x and then a positive 4. So at the end, when we combine our like terms, 9x squared minus 12x plus 4. All right, problem 20. We've got a little bit more involved multiplication problem here. Let's see here. X plus 3 times x squared minus 2x plus 9. And this is the same process we just did in problem 19. We're first going to distribute the x to each of these terms. And so that'll give us x to the 3rd minus 2x squared plus 9x. And then we're going to distribute the 3 to each of these terms. So we'll get plus 3x squared minus 6x plus 27. So we've just got the 1x cubed. And then we've got these two different x squared terms, a positive 3x squared, a negative 2x squared. So that'll be positive 1x squared. You can put the 1 in there, but you don't have to. And then we've got positive 9x minus 6x, so that's positive 3x. And then that 27 on the end, and there we go. Okay, let's see here. Problem 21. So this is mostly about combining like terms in problem 21, but we will have to distribute that negative. So we start out negative 4x cubed plus 2x squared minus 5x minus 7. And then we want to subtract 4x cubed minus 3x squared minus 5x plus 8. So let's see here. These parentheses we can just take off because there's a plus in front of this parentheses. Here we have to distribute this negative into the parentheses. So minus 4x cubed plus 3x squared plus 5x and minus 8. Now we need to combine like terms. So here's our x cubes. Negative 4x cubed and negative 4x cubed makes negative 8x cubed. Then we've got the squareds, positive 2x squared and positive 3x squared makes positive 5x squared. Now the x's cancel each other out. We've got negative 5x and positive 5x. That makes 0 x's. And then negative 7 and negative 8 makes negative 15. All right, one more problem. And this is a factoring, the greatest common factor problem. So let's take a look at that. All right, problem 22, we start out 8x squared y cubed plus 16x cubed y to the fourth minus 20x cubed y cubed and plus 12x squared y to the fifth. So I recommend to look at each piece separately. So first I'm going to look at all the coefficients and look for a common factor. They're all even numbers, they're all divisible by 2, they're also divisible by 4, and that's what we want. We want the greatest common factor. So we're going to factor out a 4 here. The x's, we've got a couple x squareds and a couple x cubes, so the x squareds we can factor out, and that'll take 2 of these 3 x's get factored out, and you'll have x to the first left here and here, and no x's here and here. With the y's, we can factor out a y to the third power. And what's going to be left here? We'll be left with a 2, and we factored out the x squared and the y cubed. So that's it. And then plus 4. Let's see. We factored out x squared from x cubed, so we're left with x to the first. And we factored out y cubed from y to the fourth, and we're left with y to the first. Here, we'll have minus 5. And again, if you're not sure what these numbers are, you can just divide this by the number that got factored out. So here, we factored out 2 of the 3 x's. Here, all of the y's got factored out. And then plus 3, the x squared gets factored out. Y cubed gets factored out, so that leaves us with y squared. So there we go. All right, so like I said, I encourage you to do the test on your own. Use this video to check your answers, and also if you want to see, how to do one of the problems that you struggled with, you have this video to refer to. But it's a really good idea to do the problems yourself first, and that helps you to be ready for the final. As always, if you have any questions, please let me know. You can contact me by email, stop by my office hours, but it's important to get your questions answered. Thanks.